Hello everyone! Welcome back to Doc Gilmac online tutorial. Doc Gilmac Math TV Basic Calculus Tutorial. Are you ready for the next tutorial? So if you are ready, let's begin. The topic I will be discussing for today's tutorial is all about the derivative of secant function. In this particular topic, I will be showing you the proof on how the derivative of secant function was derived. We need not to memorize the formula for the derivative of secant function. And also, I will be giving examples on how to use the derivative of secant function. Take note, the derivative of secant function was also derived using the quotient rule of differentiation and also the trigonometric identities, that is, secant x is just equal to 1 over cosine x, or simply the reciprocal identities, and also tangent x is equal to sine x over cosine x. In this particular proof on how the derivative of secant function was derived, we will be using the derivative of cosine function. That is, d over dx of cosine x is just equal to negative sine x dx. Consider the proofs of the derivative of secant function, d over dx of secant x. This can be written as d over dx of 1 over cosine x, applying the reciprocal identity for secant x, which is simply equal to 1 over cosine x. Applying the quotient rule of differentiation, low d high minus high d low over low low. So this is simply equal to cosine x times 0 minus 1 times negative sine x all over cosine x quantity squared dx. Take note, low is cosine x, so just copy derivative of 1, which is high, that is constant, is 0, minus high, so just copy 1, derivative of low, which is cosine x, that is simply equal to negative sine x, all over low, so we just square cosine x, so we have quantity cosine x squared. Simplifying further, this is simply equal to sine x over cosine squared x dx, since cosine x times 0 is 0, minus 1 times negative sine x is positive sine x, all over the square of cosine x, so that is simply equal to cosine squared x. Rewriting this fractional expression, trigonometric expression, this can be written as 1 over cosine x times the quantity sine x over cosine x dx. Take note, 1 times sine x is the same or equal to sine x. Cosine x times cosine x is just equal to cosine squared x. Simplifying further, take note, 1 over cosine is simply equal to secant x, and sine x over cosine x is simply equal to tangent x. This is just equal to secant x tangent x dx. So therefore, we can say that the derivative of secant x is just equal to secant x tangent x dx. So take note of that. Consider illustrative example number 1. d over dx of secant of 2x. So the given angle for the secant function is 2x. So we just apply the formula for the derivative of secant function. So we have secant 2x tangent 2x times the derivative of 2x, which is 2. since the derivative of x is 1. So simplifying further, this is just equal to 2 secant of 2x tangent of 2x. Consider illustrative example number 2. d over dx of secant of negative 4x. So as you can see here, the angle for the secant function is negative 4x. So applying the derivative of secant function, this is just equal to secant of negative 4x tangent of negative 4x times the derivative of negative 4x, which is negative 4, since the derivative of x is 1. Simplifying further, this is just equal to negative 4 secant of negative 4x tangent of negative 4x. Consider illustrative example number 3. d over dx of secant of x plus 3. This time, the given angle for the secant function is x plus 3. Applying again the derivative of secant function, so we have here secant of x plus 3 times tangent of x plus 3 times 1, since the derivative of x plus 3 is just equal to 1. Simplifying further, this is just equal to secant of x plus 3 tangent of x plus 3. Consider illustrative example number 4. d over dx of secant of the quantity x plus 1 is square. This time, the given angle for the secant function is x plus 1 quantity square. So applying the derivative of secant function, this is just equal to secant of x plus 1 square tangent of x plus 1 quantity square times 2 of x plus 1. So as you can see here, the derivative of x plus 1 raised to 2 is simply 2 of x plus 1. We just applied the power rule of differentiation. Simplifying further, this is just equal to 2 of x plus 1 secant of x plus 1 quantity square tangent of x plus 1 quantity square. Again, I would like to thank you for watching Doc Gilmac Math TV. Stand by for my next tutorial. Stay safe everyone, and may God bless us all.